Hi everyone, welcome back. In this video, we're going to set the stage for trying to find the electric field between two oppositely charged parallel plates, as you can see in the picture here. Okay, so our goal is to work out what the electric field is in between here, and we are just stating as a fact that the electric field is constant or uniform between these two plates. We're not going to prove it. It's a bit out of our league to do that in year 12. So we're just going to say, yep, that's what it is. Okay. But we're going to try and derive the value or some kind of formula for that. Okay. So what are these parallel plates? How do they come about? How do they get their positive and negative charge? Okay. Well, basically the plates are, some kind of conductive material, say metal of some kind. And the plates are, or they could be connected in a circuit like this, where you just connect some kind of voltage source to each of the plates, okay, like a battery of some kind. And what a battery does is basically you can consider it like a pump. And what happens is it removes electrons from the top plate, pumps them through and around the circuit and dumps them on the bottom plate here. Okay, so overall, the charge on the top plate becomes positive because you've removed electrons from it. Okay, electrons have negative charge. If you remove something that has negative charge, overall you're left with some positive charge. Okay, so the top plate becomes positively charged and the bottom plate becomes negatively charged, because that's where all the electrons end up. All right, so that's how you build one of these things to begin with. All right, now, when we do questions involving parallel plates, you'll be given the voltage between the plates, okay, or the potential difference across the plates, or however you want to phrase that. What is that value? Well, generally, if there's nothing else connected in the circuit, that's just going to be the voltage of the battery that you're using to charge these plates. Most questions won't show you a diagram of the plates connected to the battery. They'll just say the voltage is blah, blah, blah. Okay, and you just got to take their word for it that they've been charged and they have that voltage difference across them. All right, we also are going to be given the value of the distance or the separation between the plates. Okay, and we're going to use the symbol D to describe that, and because it's a distance, SI unit for distance is meters. All right, now again, our goal here is to try and determine what the electric field strength is in the region between the two plates. Okay, we're not going to prove that it's constant, we're just going to say that it is. We're not going to give a very formal proof. It'll just be manipulating some equations around. For a formal proof, you want to start with this thing called Gauss's law. Okay, it does involve some integrals and stuff like that, so it's out of the scope of year 12. We're just going to do a bit of a hand-wavy proof of the electric field. Okay. One final thing before we finish the video is when we're dealing with parallel plates like this, we need to assume that the length or the size of the plates is much, much larger than the separation between them. Okay, so this separation here, D, versus the length of the plate here. Okay, this is a very exaggerated picture just to highlight, the field between the plates. But generally, you'd get like a plate like that separated with a plate like that. Okay, and the length or the size of the plates much larger than the separation between them. Okay, that's the assumption that we're working with here. So there you go. Okay, where do these things pop up in real life? Well, this is very close to what we call a capacitor. Okay, it's a type of electrical circuit component, and it's used to store charge for various purposes. Okay, so it is a real life object. Okay, they do pop up. So they're called capacitors. All right, that's it for this video. Just wanted to set the stage, okay, describe what this parallel plate thing is and the values that you'll be working with. and just again to remind you that the field between them is constant, and we're working with that assumption. Okay, so stop there. We'll see you in the next video.